Okay, well, hope everybody's doing okay today. We just finished up with our spooky minutes. We'll continue that tomorrow. But Friday is the end of the 6 weeks, and remember, tomorrow morning is the deadline if you want to retake, say, last week's quiz, or if you still have a homework assignment that can be turned in, within the 10-day time period, or if you just have corrections on an assignment. All of that we need to have taken care of by 8:05 in the morning. Okay, so if you have any questions about that, just let me know. Tomorrow we'll go ahead and get started on the district assessment, probably within the last 10-15 minutes of class, and then we'll finish that up on Friday. Okay, well, we've been talking about two laws. What are they? Law of sines and the law of cosines. Now, if we're going to use the law of sines, we have to have what's known as a pair. We have to have an angle measure and the side across from it. If we don't have a pair, that's where the law of cosines is going to come in. Now, there is a special case, we call it the ambiguous case. If you're given two sides and an angle, that occasionally the values provided are just right, that you can actually create two different triangles using those same measurements. Now, what this table is designed to do is kind of help you sort through what's going on. Okay, based on the measurements that I have, will there be one triangle, will there be two, or will there be no triangles at all? It's very possible that you might not be able to form one. Okay, so you'll notice the table is broken up into two rows. The angle you're given is either going to be acute or it's going to be obtuse, and that tells you what row to look at. Well, the two sides you're going to be given are always represented by A and B. So if it's obtuse, okay, if side A is less than B, there's no triangle that can fit those particular dimensions. If A is greater than B, you're going to have one solution. Now, you also compare A and B across the top row, but there's something else you need if the angle given is acute. What's the one other variable we see there? H. What do you think the H stands for? Heck yeah, it could. That stands for the height of the triangle. So if your angle is acute, odds are you're probably going to want to know what the height is to kind of help you see what's going on here. Now, as far as finding the angle measures, finding the side lengths, that is exactly what we've been practicing the past couple of days. So really the only new aspect today is just kind of figuring out, well, how many triangles do I have? Now, they're kind of getting you to see this, but you see this curved line here that's dashed. What they're trying to get you to visualize is that one side kind of swinging back and forth like a pendulum. Okay, so let me see if I can help you visualize that. So I have this right here. So let's say that I had a side length going down. So I complete the triangle, right? But imagine that this side that I created kind of swings over, but creates a second obtuse triangle. That's what we're talking about. So this guy kind of swings back and forth and is able to create two triangles. Is everybody okay with that? Okay. So if that's the case, well, we just want to figure out, well, what's everything about those triangles? What are the angle measures and what are all the side lengths? So I think the best way is just to get right into a problem and let's see what you guys think. Okay, so this first one right here, we're back in your packet. Find all solutions for the given triangle if possible. If no solution exists, write no solution. Okay, round side lengths to the nearest whole number and angle measures to the nearest tenth. Now, here's the thing about the values you're going to be given. You're always going to be given two sides and an angle, right? Because the ambiguous case is side-side angle. It makes sense. But within that, the angle that you're given is always going to be opposite one of those sides. So as part of the side-side angle, you're always going to be given a pair. Because if a triangle does exist, you're going to need to be able to solve it. And we can solve it if we have a pair. Now, I always go ahead and create these in the same way. I start just by drawing just a normal triangle like this. The angle I'm given, I always put in the bottom left corner. So then I have the side across from it, 18, and then I have the other side. Now, the other side, I go ahead and put here, not as the base. Now, you can orient these triangles in any fashion that you like, but for me, I always found that if I just keep the pictures all the same, keep it consistent, it was a lot easier for me to see what was going on, okay? And you see that's exactly what we have over here. But the only difference is between the diagram that was provided and what I just drew, they did go ahead and drop a perpendicular segment representing the height. Okay. So because A is acute, and we just said that trying to figure out what's going on, if A is acute, odds are you're probably going to need to know the height. Well, because it's a right triangle that's created now, well, we can just go back to our right triangle trig to solve for that. Can anybody tell me what equation would help me solve for H? Or let me back up for just a second. The only angle we have is 63, right? So what would H and 25 be with respect to that? Opposite and hypotenuse. So what trig function uses an opposite and a hypotenuse? Sine. So you can always use sine to find that H. So I'm going to go ahead and say sine of 63 degrees is equal to the opposite height over the hypotenuse 25. Now remember, we weren't starting with a right triangle, but we were able to break it into two right triangles by dropping that perpendicular segment. Okay. And it's been a while since we've seen one of these, but how do you solve for H? Yeah, just go ahead and multiply through. 25 times 25. Those are going to cancel. So let's see what we got here. 25 times the sine is 63. Let me go ahead and get rid of this. 25 times the sine, 63. So I'm getting, let's say, 22.3. Okay. Now come on over here. So this is 22.3 units. Now we know because I'm given an acute angle, I have to be in the top row of that table. But now let's go ahead and do my comparisons. How do A and B compare to each other? Are they equivalent, or is one greater than the other? What would I say? A is less than, A is greater than, or A equals B? A is less than B, right? 18 is less than 25? Well, how does side A compare to the height that we just found? A is less than the height as well. Okay. So everybody sees my comparisons here? So I know A is less than B, and I know A is less than H. So using this information, I come on over here to the table. We know we're in the top row because we're acute. So what happens when A is less than B and A is less than H? You'll notice the only one that fits both is right here. So that means that no triangle can exist with those measurements. Now, if A had been less than B and A equaled H, well, you'd have only one triangle. If A was less than B but greater than the height, that's when you're going to get two solutions. So that's what the table is for. It's just kind of help you distinguish between what's going on. So I'm going to come back over here. I'm just going to go ahead and put no solution. It can't happen. Floss? You're not going to have to memorize it. In fact, say for a quiz and a test, if I don't have it on the board, I'll go ahead and let you use like a little note card or something. And I'll tell you specifically, you definitely want this on that card. Okay. All right. So now let's say that you're having trouble with the table, or you don't even look at the table and you just go ahead and push forward and try to solve the triangle. Okay. Now, even though the diagram may not be correct, I can draw a triangle with those values. So this is A, this would be B, this is C, 63 degrees for angle A. We know across from it is 18, and we have 25 here. So like I said, let's go ahead and just push forward and try to solve and see what happens. Okay. Well, what's the first thing I'm able to solve for? I can solve for angle B, right? Because I do have a pair. So based on what we said the past couple of days, I'm going to take the sine of 63 degrees over 18 equals sine of B over 25. Now, very important question. Will I be taking the inverse? Yes. If you're looking for an angle measure, you will be taking the inverse. If you're looking for a side length, you will not be taking the inverse. Okay. Well, we solve these by cross multiplying. So this is going to be sine of B is equal to 25 times the sine of 63 degrees, all divided by 18, right? Okay, so let's do like we did the past couple of days. 25 sine of 63. So let's see here, control divide. 25 sine of 63, and I'm going to divide that by 18. So I'm going to get this value here. This is what equals sine of B. So now I'm going to take the inverse with that value. So sine inverse of this. Now remember, what did the table say? Could a triangle exist with these values? No, it said no solution, right? So my point is, even if you push forward, you're still not going to be able to create a triangle. At some point, something's not going to work. Does that make sense? Okay. All right, well, let's try another one. Let's see what you guys think. Okay, let me come back over here. Remember, the only new aspect today is going to be the table. As far as finding the missing angles, the missing sides, that's something we've been talking about for a couple days now. Let's try this one. Okay, so same thing. Find all the solutions if possible. Side lengths to the nearest whole number, angle measures to the nearest tenth. Okay, so you'll notice again, look at the consistency. I've got a pair, angle A and the side across from it, and I'm always going to start by putting that angle in the bottom left corner. Okay. Then I've got the 73, the 55 would be this other side. Okay, it's never the base. All right, so let's see what we got here. What kind of angle do we have for A, though? Okay, it's obtuse. So if it's obtuse, you don't need to worry about the height. So that's one less thing. So if it's obtuse, there's only two solutions. Either you're going to have a triangle or you're not, and it depends on A and B. Well, how does A compare to B? A is what? A is greater than B, right? So according to this table over here, what's going to happen? Yeah, a triangle can exist with those values. Now, if we had an obtuse given to us and A was less than B, then we wouldn't be able to create a triangle with that. Okay. But is everybody starting to see how the table works? It's just designed to help you figure out how many triangles, if any, there will be. Okay. And now the rest of this problem is, just like we've been doing. Where would you like to start? Angle B? Okay. So somebody give me a proportion using the law of sines that'll help me solve for B. Okay, so I heard sine of 105. Okay. Over the 73 equals sine of B over 55. Okay. Now, let me go ahead and show you something right quick here, and some people have probably already been doing this, but everybody's okay with the proportion? Okay, so I'm going to cross multiply. I'm going to get that the sine of B is equal to, somebody's not? Okay. Oh, all done? Okay. If you'll put that in the tray, man. So this is going to be 55 sine of 105 degrees all over 73, right? Well, why don't we go ahead and just cut out the middleman? Instead of finding the value of that expression and then taking the inverse sine, why don't we just take the inverse sine of that expression? Let me show you what I mean. So we're going to say the inverse sine and actually type in what we have here. 55 sine of 105, and we're going to divide that. Was it 73? So see, in this case here, we're not going to have any idea what value that gives me, and it really doesn't matter because now I'm going to immediately be given that angle measure. So if you want to start doing this, or if you have already begun to do that, that's fine. But I'm getting 46.7 for angle B. .7 degrees. Okay. Well, how does that help me find angle C? Yeah, I got to do a subtract now. So let's see here. 180 minus the 105 minus, what do we get? 46.7. So I'm getting C to be 28.3. Okay. And what is the only part I have left? All we need is that side C. Okay, the base of the triangle. All right, so I'm going to set up just another one. And again, I like to use the original pair. You can switch it up if you want to. But I'm going to go ahead and say sine of 105 degrees over the 73 is equal to, well, we just found C to be 28.3 degrees. And we're going to put that over little c. Okay. Now we're rounding the side lengths to the nearest whole number. So somebody help me out. What should I be getting for that base side? 17.1? Ooh, a little off. I got 36 because it's like 35 point something, right? Okay. Satish, do you want me to go ahead and put that in the calculator? Okay. Is that what everybody's getting is 36? Okay. So see, it's just another day where we're practicing finding the missing parts of the triangle or triangles. It's just that we're trying to figure out from the chart how many triangles do I have. Okay. So this next one, I'm not necessarily going to solve the triangle here, but again, I just want to really work through the table. So this one says, okay, find all solutions if it exists. Okay. Let's see here. Round side length, nearest whole number, yada, 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 all that good stuff. Well, what do we know about angle A? Is it obtuse or acute? Okay, obtuse. So if it's obtuse, do I need to know the height? I do not. I don't need to worry about that. How does A compare to B? Looks like A is greater than B, right? So with this information, I'm going to take a look at my table here. I know it's obtuse, so I'm in the second row, and A is less than B. So once again, I know that a triangle can exist with those values. Okay. Now, if A had been less than B, well, we wouldn't have to do anything. So I'm going to come back over here. I'm just going to go ahead and quickly draw a little triangle. If I can draw a triangle, because that one sucked. There we go. And I drew it to be obtuse because we have that angle A is obtuse. So this would be 126 degrees. Remember, I always put my angle given in the bottom left corner. The side across from it is 18. And the other side, I don't make him the base, I make him this other one. Okay. And then this would be B, and this would be C. Okay. Now on this one, again, I'm not going to worry about finishing off the rest of it. You know, that's something you can do. It's in the notes. Again, I'm more interested in getting to those problems where we have two triangles. So why don't we go ahead and take a look at that. All right. So the ambiguous case, two solutions. All right. Now, I will go ahead and say that right off, this diagram is a little misleading. You remember how I showed you when we first started the one side? This side right here, in fact. Let me go ahead and choose a color. This side right here that I'm highlighting in purple, that he would swing back and forth. Okay. Well, that is this guy right here. So he is 18 units long. We're not saying that the height is 18. So that diagram is not constructed very well. Yes, sir. No, sir, sorry. Not during class. Okay, now if we finish up, I'll let you go. Okay. All right, so let's go ahead and take a look at what we have. What do we know about A? Acute or obtuse? It's acute. So does that probably mean I need the height? Okay. So let's go ahead and find the height here. So if I drop that perpendicular segment, what trig function can I use to help me out here? Remember, the first time around, we went ahead and used sine. So we said sine of 45 is equal to the opposite height over the hypotenuse 24. Okay, so let's multiply through by 24. Those are going to cancel. So somebody help me out. I'm looking for 24 times the sine of 45. 16.97. So let's go ahead and say 17. So let's say our height comes out to 17. Well, let's do our comparisons. Now, even though they changed the side here, do you notice that they still put side C in the same position? We're just now calling this C and this B. So that changes nothing. All right. So even though it's C, we're just going to pretend it says C in the table. Okay. So we know that A is less than C. And how does A compare to the height? A is greater than the height. So these are the values we know. If I come back over here to the table, okay, let me get rid of this one right here. Well, we know it's acute, so it has to be in the top row. We said that A was greater than the height, but A was less than C. Now, again, our table says B, but don't let the fact that they changed the letter worry you. So what's going on here? Yeah, this scenario has exactly what fits my values. So I know there are two different triangles here. Okay, so what are those two triangles going to look like? The second one is always going to be obtuse. All right. So let me go ahead and distinguish these with some different colors here. So you're going to have the one big triangle right here. So let me go ahead and highlight him in green. Okay. And then when that side swings over like a pendulum, you're going to have this obtuse triangle right there. Okay. So I'm color coding these guys to hopefully make it a little bit easier for you. All right. Now, what we know so far about the two triangles is going to be the same. This bottom left corner, that's A, and we know he's 45 degrees, right? So I'm going to put 45 degrees. This one is still A. He's still 45 degrees. Okay. What's the side across from A? 18. So this one is 18, and this one is 18. We also know the side across from what's given to me is angle C. So I know this is the 24, and this is the 24. Now, here's the thing. This is angle C right here, so this up top would be angle B. Let me go ahead and ask you, once that side length of 18 swings over to create the second triangle, will this angle right here, C, be the same as this angle here in the purple? No, so we can't call it the same name. So let's just call it something like C prime. And the same thing's going to happen for B. It's not the same measurement, so we'll go ahead and say B prime. Okay. Is everybody okay with how I set this up? So again, the only thing, we're just solving for the missing parts of a triangle. We just have two. Okay. Now, there's one thing you can do that's going to make this go really quick. All right. Look at that first triangle. What can I solve for? Okay, we got to solve for angle C, right? All right, so let's do that. Sine of 45 over 18 is equal to sine of C over 24. Will I need to take the inverse? Yes, because we're trying to find an angle measure. Okay. So let me see here. If we cross multiply, I'm going to go straight into it. So angle C should equal the sine inverse of 24 times the sine of 45 all over 18. Where's my paper? Can somebody help me out with that? Oh, for here. Let's go ahead and round it to one decimal place. Okay, 70 point what? I got 70.5. That's exactly right. So 70.5 degrees. Is everybody okay with that? Now, by finding that one angle, look at how quickly a lot of the rest of this goes. Well, what do I do to find angle B? Yeah, just subtract, right? So what's 180 minus 70.5 minus 45? That's 64.5. Okay. Now, check it out. Look over here in this diagram where it shows you this guy swinging back and forth. Specifically, this triangle right here. If those two sides are the same length, what kind of triangle is that? Starts with an I. That's isosceles, right? Now, we also found that this bottom right angle was 70.5, right? 70.5 degrees. Does that help me in any way? What do we know about the base angles of an isosceles triangle? They're the same. So if this is 70.5, then this is 70.5. Well, how does that help me in the second triangle? There you go. Because right here, wouldn't this angle be supplement to the 70.5? What is that? Okay, 109.5. This angle right here, 109.5. Well, that in turn helps me get what? Yeah, B prime. So what's that remaining angle? Now that we know the obtuse on the second is 109.5. Ooh, a little off. I got 25.5. But do you see how once you have the two triangles created, by finding this angle first using the law of sines, I was then able to find this remaining angle. Then I was able to find this one and that one. Okay. With just doing some simple arithmetic. Now, what's the only thing that's left? You got to find little b and little b prime, right? Okay. So let's say we set up a law of sines to find little b. So I'm going to say sine of 45 over 18 is equal to, well, we have b is now 64.5. The sine of 64.5 over b. Okay. Now, just for the sake of time, you go ahead and solve that, you round it, you should be getting something about 23. Has anybody already figured out what little b prime is? Okay. It is 11. That's what I got. And there you go. That's it. The only new aspect to today is just that table. Anybody having a hard time? Anybody confused? Okay. Well, let's go ahead and try another one. In fact, I believe this will be our last one. Okay. Find two triangles for which A equals 24 degrees, A equals 13, and B equals 15. Okay. Now, it already says find two triangles, right? So odds are pretty good that there's going to be how many triangles? Probably going to be two. But again, let's just run through that table to make sure we feel comfortable with it. What kind of angle am I given? Acute or obtuse? Acute, so I'm definitely going to be looking in the top row. Now, if it's acute, I probably need what? I need the height. Okay, so let me go ahead and set this up. I'm always going to put the angle I'm given in the lower left corner. So here's 24. The side across from it is 13. The other side would be 15. Now, because that's given to me as B, I know that's angle B and this is angle C. So now from angle C, I'm going to drop a perpendicular segment down. That's my height. And what trig function has been helping me find that height? Sine, yeah. So I'm going to say sine of 24 degrees equals the opposite height over the hypotenuse 15. Go ahead and multiply through. These are going to cancel. So somebody help me out. What are we getting for the height? Like 6? Okay. Does anybody want to see it in the calculator, or are we good? All right. Well, let's look at our comparisons. 13 and 15, so I see that A is less than B. And how does A compare to my height? A is greater than the height. So I want the scenario that fits these circumstances. If I come back over here, again, A is less than B, but greater than the height. Okay. All right, well, let's go ahead and set these two guys up. Remember, we're going to have this much larger one right here. And then this other one is going to be an obtuse. So again, just as I said in the beginning, I always draw my two triangles the exact same. They may not fit appropriately to the values we're going to find, but it just helps things go a lot smoother. Okay. So I know that this bottom left corner is A. That's 24 degrees. A, 24 degrees. I know across from it we have 13. So this is 13 as well. We know that across from angle B, we have a side that's 15 units long. So this one's 15. This one's B, and this one's C. But remember, when that side of 13 swings over to create the second triangle, angles B and C are not going to be what they originally were. So we're going to call these B prime, C prime. All right. And from here, we just start solving. Okay. What's the first thing I should solve for? I'd go for angle B. What proportion is going to help me do that? So let's see. Sine of 24 degrees over 13 equals sine of B over 15. Will I need to take the inverse? Yes. distracting. Every time I look over there, I keep thinking someone's hand is up because it's so high. Gotta tell you, that's a pretty appealing costume. Okay. Unfortunately, you know, when the bell rings, you'll have to split. For the people at home, he's a banana, so those puns are on point. Okay. All right. So let's see here. If I cross multiply, I know that B is going to equal the sine inverse of, I would have 15 times the sine of 24, all divided by 13. All right. So somebody help me out. What are you getting for angle B? I got 28. Okay. So this is 28 degrees. Everybody's okay? Now, finding that first angle will help me also find angle C. So 180 minus 28 minus 24. I got 128. Good. Now, by finding this angle of 28, see, that helps me to find this other angle that I'm calling B prime. Because here's the larger triangle. There's B, right? We just found him to be 28 degrees. Well, remember, if these are congruent, then the base angles have to be congruent as well. So now, what's 180 minus 28? 152. So I know that the obtuse angle right here has to be 152 degrees. And now by knowing those two, we can go ahead and finish off with C prime. I got 4. That's exactly right. And what is the only thing left for these triangles? Yeah, all you got to do is go ahead and find little c and little c prime. So if I want to set up a proportion to help me find c, I'd probably say something like sine of 24 degrees over 13 is equal to, now we're trying to find c, so I have to use angle c, sine of 128 over c. So somebody help me out. What should I be getting for that? I got 25. That's exactly right. Okay. And then over here, we can go ahead and set up a proportion as well. And you can go ahead and confirm this. But little c prime, I got 2. Okay. And there you go. That's it. That's what we call the ambiguous case. Is everybody okay with that? All right. Well, I'll tell you what. Juan, it is a little past, but if you still need to go, you can go ahead and run real fast. Okay. Well, okay, if it's a cramp, then you can absolutely stand up. Okay. But anyways, I guess you don't need to go. All right. Let's go ahead and get those calculators back on the charging stations up front.